In this video, we're going to talk about Aurora Backtrack. This is one of the coolest features in Aurora. What is Backtrack? Backtracking means rewinding the database to the time specified. It's like an undo operation when a mistake is committed. Let's say you delete some data by mistake, and you want to go back in time. You can do that with Backtrack. This is a really useful feature, and is only available with Amazon Aurora. One important gotcha to remember is it's only available with Amazon Aurora MySQL compatible version. It's not available with RDS and is not available with Postgres compatible Aurora. Okay? This is very important to note. One other thing is you can go backwards and forward again within a specified target window. We're going to learn more about the target window in the upcoming slides. But let's say you specify a target window as 12 hours. There's a mistake and you want to go backwards. You can go to the past in the history up to 2 hours, let's say. And then you can also roll forward again into the future. Let's say up to 1 hour in the future, multiple times within the target window. That is the feature you have with Aurora MySQL. Okay? Now, other gotchas you need to remember. Backtrack can only be enabled during the creation of Aurora cluster. Let's say you already have Aurora MySQL cluster running in production, and you want to actually enable Backtrack by modifying the configuration. It's not possible. This is really important to remember. When you provision Aurora cluster, you need to do that at that time. You cannot do it once it's provisioned and deployed and being used in production. The second gotcha is during the backtrack time, the cluster will be unavailable. Let's say there's a mistake, data mistake, and you want to roll back the databases in the backtrack feature. During that time, the entire cluster will be unavailable. One other important thing is you need to backtrack the entire cluster, not a specific table or database. Let's say your cluster hosts 10 databases, and within each database there are an average of 40 tables. You need to roll back the entire cluster, not a specific table or specific database. Okay? That is one important thing you need to remember, okay? Don't forget that. As discussed before, you can take forward or go backward as needed within the target 72 hours. The maximum available target window you can specify is 72 hours. What is target window and what is available window? We will discuss this in the upcoming slides, but remember that the 72 hours is the maximum for a target window. Another important gotcha is cross-region replication is not supported. If you have a build log replication, which is cross-region, you cannot use backtracking there. These are important gotchas to remember, and the main thing is, as discussed before, it's only available with Amazon Aurora MySQL and not Postgres version. So please remember that, okay? Coming to target, backtrack window versus actual backtrack window. This is an important term to remember if you use this feature. When you enable backtracking, you specify a target backtrack window. For example, you may specify target window backtrack window of 24 hours. If you want to backtrack the DB cluster within 1 day, so let's say your SLA is that you want to roll back for 1 day. Like, let's say today is Friday, 10 a.m., and you want to roll back to Thursday, 10 a.m., which is 24 hours. Then you specify the target window as 24 hours. Let's say your SLA is 2 days. And then you specify the target window as 48 hours. Within 48 hours, you can go back into the history anytime in the 48 hours, which is really cool, right? Let's say you have a release that went in 1 day back, and that release caused some issues to the data and you want to roll back to the 25th hour in the past. And you can do that. Configure the target window according to your business SLAs. Okay? That's the best approach. What is actual backtrack window? Once you configure the target window, it is not guaranteed always you will be able to recover to that window. Okay? Sometimes there are some exceptional scenarios where the storage is not enough, and the actual backtrack window is less than the target backtrack window. The actual backtrack window is the actual amount of time you can backtrack your DB cluster, which can be smaller sometimes than the target window. You specify the target window as 24 hours, but let's say the actual backtrack window says you only recovered up to 22 hours. Then that's a problem, right? Sometimes that can actually happen because of the storage issues. We're going to discuss more on that topic. Why can the actual backtrack window be smaller than the target backtrack window? Okay, let's say you keep the target window as 72 hours, which means you can restore the database cluster to any point in time within the past 72 hours. And there are going to be a lot of changes recorded during this window. And as a result, it could not keep all the records due to the storage constraints. Let's say your target window is 72 hours in this case, but you have a lot of writes going on, and a lot of updates, deletes, and a lot of changes going on the database due to the heavy load that came in. Due to the storage constraints, it may not be able to recover to the 72-hour target. Okay? There can be cases like that, and you need to monitor those cases. That's why actual window can be smaller than the target window, which needs to be monitored all the time. When backtracking is enabled for DB cluster, if you delete a table stored in DB cluster, Aurora keeps that table in the backtrack change records. It does this so that you can revert back to a time before you deleted the table. If you don't have enough space in your backtrack window to store the table may be removed from the backtrack records eventually. Now, this is another important note to remember. Now, let's say you drop a table. When the backtracking is enabled, it's going to store the entire table, okay? So that you can revert back if there is a need. If the table is huge, let's say you have 1 terabyte table, sometimes it may not fit. These are some of the cases where the actual backtrack window can be smaller than the target backtrack window. There are some scenarios where you will not be able to recover meeting your SLA. You need to keep track of that and get alerted when something like this happens. Typically, the actual backtrack window is smaller than the target window when you have extremely heavy loads on your DB cluster. Okay? This is the point to remember. When you have extremely heavy workloads, let's say a lot of updates, deletes, inserts happening, which creates a lot of change records. In those cases, this can happen, like the actual backtrack window can fall apart. Okay? Now that we've gone through the theory part, let us see a demo. In the demo, we're going to create an Aurora MySQL cluster with a 24-hour target window. Once the cluster is created, I'm going to create an employee database, which is a sample database, a department table, and insert some sample data. Once that is done, I'm going to take a snapshot of the current schema and data. So I would just want to see the schema definition and the data before we drop it. Once we take the snapshot, and then we drop the table and database, the employee database and the department table, and then we capture the current timestamp because we need to backtrack to that point. So we need to capture that. And then we perform backtrack. Once the backtrack is successful, it's going to take some time, and once it's successful, we need to make sure that the data is recovered. Whatever is dropped, so we drop the employee database, we drop the department table and the data. So those elements should be restored as is. Let's go and do the demo. See you guys in the next video. Take care.
Cloud DB School. Either we adapt or we slowly fade away. So what's happening in the DBA space? The DBA role is evolving. Either we adapt or we slowly fade away. This is correct. So what about this quote here? DBA role is dying. RIP DBA. This is wrong. DBA role is not going away. There's nothing to worry about. Social proof. Jonathan Lewis, a world-class Oracle expert, I'm worried about the future of DBAs. This is a quote taken from the internet. Either we adapt or we slowly fade away. I was a DBA too, but made the transition to DBE, so it's an evolution. This is a quote taken from a DBA. Major technology trends are reshaping the DBA role at many organizations. This is another quote we found from another article on the internet. Oracle and SQL Server DBAs should learn Postgres, MySQL, Ansible, RDS, Aurora, DynamoDB, automation, etc. RDS Aurora needs database engineers, especially when there are many RDS instances. A Google search for death of the DBA or DBA title dying will yield something like this. This is an example, an excerpt of Google search results. So how do we evolve? Learn open source, Postgres and MySQL, learn RDS, learn Aurora, learn DynamoDB, cloud migration techniques, GCP Postgres and MySQL services, Azure Postgres and MySQL services, automation using Ansible, Terraform, and more. These are some of the technologies you should learn in order to evolve. How Cloud DB School can help you. Currently, you can learn the below by enrolling today. More topics will be added on a monthly basis. Postgres, RDS, Aurora, DynamoDB, cloud migration using SCT and DMS, and you can prepare for the AWS Database Specialty Exam. Again, more will be added each month. Here are the courses you can enroll in today for Postgres. Postgres Architecture, Installation, RPM and Source, User Access, Backup and Recovery, Streaming Replication, PG Bouncer, PG Pool, Monitoring, PG Stat Statements and PG Stat Activity, Monitoring PG Badger, and Monitoring Prometheus and Grafana based. For Aurora, you can learn creating Aurora Cluster with Terraform, connectivity issues, restoring from on-prem server to Aurora Cluster, Aurora Backups and Restores, monitoring Aurora Cluster, Aurora Global Cluster, Aurora Cloning, Aurora Backtracking, and Aurora Serverless. For RDS, you can learn creating RDS using Console, CLI, or Terraform, RDS Backup and Restores, RDS HA, multi-AZ versus read replicas, managing RDS, stop, start, and modify, RDS monitoring, events and alarms, RDS versus Aurora. For DynamoDB, we offer DynamoDB Introduction, DynamoDB Consistency Levels, Querying DynamoDB, DynamoDB Backup and Recovery, DynamoDB Global Tables, and DynamoDB TTL. We also offer database migration courses with SCT and DMS, showing you how to use those different demos. If you use Oracle, SQL Server, MySQL, Postgres, TB2, or Sybase, any of these courses that we offer may be helpful to you. Again, we will be offering new courses every month. So the question is, why should you pay $4.99 per year to enroll? We offer our services for a one-time fee of $499 US per year to enroll, roughly $41 per month. With this, you get access to all of our current courses to enroll in, along with any that will be added within your year of enroll. You'll get access to Postgres, RDS, Aurora, DynamoDB, Cloud Migration, and AWS DB specialty courses today. More courses will be added on a monthly basis, and all new content will be available to you as we publish it. Automation courses are coming soon. You can check our Cloud DB blogs to see our previous work in this space. The DBA role is evolving. Accept the change and start learning and acquiring new skills. Either we adapt or we slowly fade away. Here are some of the most frequently asked questions from our website. Can I get a free trial? Will I be able to clear AWS Database Specialty Exam after enrolling? I'm an Oracle SQL Server DB2 Sybase MySQL/other DBA. How will I benefit from your courses? How will I contact you if I need more information? Answers to all these questions and more can be found on our FAQ page on our website. And remember, if you need any additional information, feel free to reach out to us.